You can see we are in a mode of having to make do because Cirque is going to be on tonight, and so the screen is blocked from the top. It may be difficult for some of you to see some of the things that are on here. If it is, I would suggest you move forward if it is. On the other hand, we're fortunate because about a third to a half of this lecture I'm just going to be reading to you from the $1.99 novel that you can get on Amazon. And by the way, I've extended the time, so if you can't download it or any of the books over the course of the journey, you can get home and you can download it then. Just put my name, Kuznetz, and Amazon into Google, and these books will come up for $1.99. So I'll keep it that way for a couple of months, so hopefully you can get it. So Mars. Let's take a nice view, a panoramic view of this place. Kind of looks like a lot of places we've been. No sign of anything living, but kind of looks like a friendly place, doesn't it? Look at that sky. Look how flat that sand is. You'd never know it's about 100 degrees below zero there. And then you know you're not quite in the place you think you are because of this that bounces into the view, which is Opportunity rover. And you see mountains in the background and very friendly. Why? Why is this place of great interest? Well, the first question you might ask is, why go to Mars? Some of you will say, well, one reason is here. Here's Arizona. Here's Mars. You saw the image just before. They look pretty similar. However, here's a good reason not to go. Earthlings, go home. We don't want you here. So what we're going to talk about today, and this is in two parts. We're going to talk a little history, what do we know, how will we go, and why will we go. And the first part, today's part, is going to be how we got to this point in time where this is such a riveting topic in the space science and human interest world. So let's start with a little history. In the beginning, we had only our eyes to look at when humans emerged from caves and looked up at the sky, and they noticed this red orb up here and started to imagine. And because Mars was blood red in a black sky, it was known in ancient times as Ares, the god of war. And of course, we're great at imagining things, and we started to take off on here. And then we began to invent things, and humans became smarter and used technology to first peer up at the heavens. And in 1777 to 1783, Sir William Herschel, who was a British Astronomer Royal, studied Mars with telescopes that he built himself. The early telescopes were not designed to look up, they were designed to look down. So it took a while for the telescopes to get to the point of looking up. And when he looked, he believed that all planets were inhabited. Intelligent beings lived in a cool area under the surface of the sun. I mean, some of the stuff is outrageous, but as we'll talk about later, outrageous things become real, and real things become outrageous in science sometimes. And then a little bit later, Giovanni Schiaparelli announced using another telescope that he had discovered Canali on Mars, and that is a maritime world surrounded by seas. And he plotted this in great depth with lines everywhere. Now, there was a little problem, you see, because Giovanni Schiaparelli was, of course, Italian. And the word canali in Italian was mistranslated. It was improperly translated to canals when the real meaning is channels. There is a fundamental difference between a canal and a channel, isn't there? A canal is something, it's implied to be built by something intelligent. Then we got a little crazier here. And in 1895, about 100 years later, Percival Lowell came along. Now, Percival Lowell was a part-time astronomer and a full-time textile manufacturer. He had a vivid imagination, like everybody else studying this topic. And he set the stage for what was to follow. And he built an observatory, which is still there, the Lowell Observatory, in fact. There are a couple of wonderful people in the audience, Jerry and Selma, who are gatekeepers for the Lowell Observatory and trying to secure funding for some of the upgraded telescopes and programs that are there. And, but back in the day, Percival Lowell didn't know about any of that. He just looked at Mars himself. Here he is looking at Mars. And he saw these images here. And you can see as he saw, these are his images. And he did drawings. And when you look at the images over time, things seem to change. And he came to some conclusions. He concluded in widely circulated writings. Now, I should say widely circulated in the day is not widely circulated today. This was a very tiny, tiny audience that was interested in this stuff, and they had to go to great lengths to get these writings. So widely circulated means among his peers. The broad physical conditions of the planet are not antagonistic to some form of life. There's an apparent lack of water upon the surface, and beings would need a resort to irrigation, canali, to support such life. There's a set of spots where we find the lands behaving as oases, and a chain of reasoning by which we regard it is probable that upon Mars we see the effects of local intelligence. That is not all that Percival Lowell did, you see, because what he did was he set the stage for two guys with the same last name who changed the picture of Mars completely in a much bigger way. Now, their names weren't spelt the same. H.G. Wells, W-E-L-L-S, Orson Welles, W-L-L-E-S. They never met until the end of their lives, later in the day. But what they did together, although poor H.G. didn't see this one coming, was just smash Mars into our consciousness.
Good evening, ladies and gentlemen. From the Meridian Room in the Park Plaza Hotel in New York City, we bring you the music of Raymond Raquello and his orchestra. With the touch of the Spanish, Raymond Raquello leads off with La Cabecita.
Ladies and gentlemen, we interrupt our program of dance music to bring you a special bulletin from the Intercontinental Radio News. At 20 minutes before 8 Central Time,
A huge flaming object, believed to be a meteorite, fell on a farm in the neighborhood of Grover's Mill, New Jersey, 22 miles from Trenton. The flash in the sky was visible within a radius of several hundred miles. The noise of the impact was heard as far off as the distance. He is attached to the Central Mobile Unit to the scene.
Ladies and gentlemen, this is Carl Phillips again, out at the Wilmot Farm, Grover's Mill, New Jersey. Dr. Kirsten and myself made the 11 miles in 10 minutes. Well, I hardly know where to begin. Thanks to your word picture of strange things before my eyes, but nothing out of the modern Arabian Nights. I just got here, I haven't had a chance to look around yet. I guess that's it. Yes, I guess that's the thing directly in front of me. Very good. Nothing happening. Ladies and gentlemen, Mr. Griffin. This end of the thing is beginning to break off. The top is beginning to rotate like a screw, and the thing must be hollow. Wait a minute. Someone calling somewhere or something I can see. Turning out that black hole through a luminous disc. For the eyes, it might be a face, might be all the heavens. Something wiggling out of the shadow like a great snake. Now it's another one, and another one, and another one. They look like tentacles to me. There's something happening. A shape is rising out of the pit. They make out a small beam of light against the mirror. them head on. Lord, they're turning the plane. You caught on the wood of fire. There's damn tanks in the automobile. Spreading everywhere. Coming this way now. About 20 yards to my left.
Ladies and gentlemen, due to circumstances beyond our control, we are unable to continue the broadcast from Grover's Mill.
This time we take you to Washington for a special broadcast on the national emergency. The Secretary of the Interior.
Citizens of the nation, I shall not try to conceal the gravity of the situation that confronts the country, nor the concern of your government in protecting the lives and property of its people. However, I wish to impress upon you, private citizens and public officials, all of you, the urgent need of calm and resourceful action. Fortunately, this formidable enemy is still confined to a comparatively small area, and we may place our faith in the military forces to keep them there. In the meantime, placing our faith in God, we must continue the performance of our duties, each and every one of us, so that we may confront this destructive adversary with a nation united, courageous, and consecrated to the preservation of human supremacy on this earth. I thank you.
Could we bring up the lights a little bit, please? Okay, so back in the day, there was no internet, there was no television. The Mercury Theater on the Air was the single biggest media attraction in the US of A. You saw images of people sitting around their radios, and that's what they did. And every now and again, the Mercury Theater on the Air would come up with a radio play, but most of the time it was dance music, like you saw. And when they did a radio play, they would usually make multiple announcements. But you see, Orson Welles had a different idea. There was one announcement made in the beginning and no announcement made after that. And anyone tuning in, and of course I've condensed this down. The real tape is much longer than this, and it goes to much greater detail and length and all those things. But anyone tuning in was literally convinced that this was a real event, and the next day the New York Times was covered with radio listeners in panic, taking drama as fact. Now you might take a look at the date, October 31st, 1938. What is October 31st? Halloween. People didn't think about that. So they burst into the street, and Orson Welles was corralled by the police and taken into police headquarters, and of course he made his entire career on this. This was the jumping point for him to become famous. Here you see some of the actors playing in their roles. Every now and again, I've been able to find people who are actually around during this time, and they've relayed stories to me about how that was. I don't know if anyone in the audience was around then as a child and might have bore witness to this panic. By the way, this was repeated in Europe 2 more times after the fact with exactly the same results. You'd think they would have learned. They didn't learn. Same thing. To show you how serious this was a picture that one of these people, one of the folks in the audience sent to me, and is purported to be, believe it or not, one of the great machines that they confronted in the woods, actually a water tower that they shotgunned, and here you see it toppling over. So this was very much in our in our face after the War of the Worlds incident. But it only began a long chain of events of misunderstandings and panics and imaginings that relate to Mars. Craziness continues to the present day. We see things like a face on Mars over here. We'll come back later and look at a different imagery, higher resolution, and it's some sand. We've made movies about this, so this all gets back to what do we actually know as we started to move along in technology. The first spacecraft to visit Mars was Mariner 4 in 1965, and it sent back close-up images of the surface, and it revealed a cratered and pock-marked terrain that looked like the moon. And the idea of life on Mars disappeared like when that happened. But again, when it comes to Mars, things are not what they appear. Mars has something called a hemispherical dichotomy. The southern hemisphere looks nothing like the north. And if you go north, you see some of the images I showed you in the beginning. But that and images like this later on in 1971 by Mariner 9 observing a sandstorm raging across the entire planet's surface, adding to the impression that this was a violent, inhospitable place. Everything changed again, however, in the bicentennial year. And at this point, I've got to read to you. Hope I can read it in this light. Let's see. From Cassie's Guess, and you get a little sense of things, I hope. It was a speck searching for another speck in a fathomless jet black sea. 13 months it tracked its prey, speeding up, slowing down, speeding up again, like a bloodhound in the vastness. 13 months through danger-littered paths that had left it bent and broken, but alert, very alert. As it probed ahead, its silvery body reflected a reddish glow, the only hint of color in an otherwise ashen sea. It came from the target, growing bigger by the second. And now, 394 days after it began a 400 million mile one-way journey, fewer than 100 remained. Sensing the approaching moment, it slowed time down within it, splitting seconds into milliseconds, milliseconds to microseconds, each with a shred of information to help chart its next move. Across the void, its creators sent it to and sent a signal, kvugging, that took 40 minutes to arrive. Following orders written long in the past, it began a series of steps known as approach sequence. From that moment on, the creators couldn't help it anymore. From that moment on, it was utterly alone. Preparing for heat, it tucked long legs tightly in a turtle-like shell and fired tongues of flame in the opposite direction. Again and again it fired, but an inferno arose and temperatures kept building. Deep in its brain, calculations were at light speed, computing commands to keep it on course, staccatos of impulses at just the right time. There could be no error as it raced down the corridor of final approach. Straying by centimeters meant incineration. 40 kilometers from target, it maneuvered its shell to face the heat head-on. And suddenly, winds and an outline of something opaque appeared. It jettisoned its shell and released its parachute at 5 and saw a splotch of terrain, but it was covered with canyons and gorges. A flat spot in the distance seemed a good place to land in. But it was not. Boulders and craters were everywhere. Hurtling down 500 feet a second, it was powerless to change things. Its fate was in the hand of its chute, winds, and luck and engines. At 10,000 feet, it unfolded its legs to brace for impact. At 5,000 feet, engines ignited to cushion its fall. By 1,000 feet, it had slowed to 100 feet a second, and suddenly small sense organs in its footpad touched something solid. Time to stop, shut down, initiate arrival transmission. It was July 20th, 1976, and pops from champagne corks rang out in a room at the Jet Propulsion Laboratory. Viking 1 had just become the first human object to land on planet Mars. Viking had little time to waste on the sands of Chris Planitia. Locking its cameras on the ground surrounding it, it dissected the scene one line at a time. Left to right the dissection went. It was married to filters, transformed into pixels, and then sent long distances back to the Jet Propulsion Lab in California, where a black and white mosaic began unfurling on a screen like a butterfly from a cocoon. A pitted stone came forth, sharply focused pebbles, fine sand, the shadow of a landing strut that meant it was late in the afternoon. Viking began taking more photos, panoramic scans of its landing site, three-dimensional views from different angles, zooms to the horizon, and close-ups. It passed black and white images through red, green, and blue filters to get color, and used an ingenious color chart and an American flag on its body to true the colors. From there, it went to the data gathering phase, switching on seismometers, spectrometers, and samplers. In the weeks that followed, an alien starkness was revealed, striking yet somehow familiar. There were wind-blown sands, rippling dunes, rolling hills. There were desert vistas that smacked of home. There were towering mountains, ancient riverbeds, ice-covered polar caps. Well-known forces could be seen at work: landslides, erosion, winds, clouds, storms, and seasons. There was a towering volcano 15 miles high and 24 miles across, a canyon that gashed the equator for as far as North America was wide. There were yellow clouds, carbon dioxide frost, mysterious craters. And then there was the water. No sign of it. No rivers, no oceans, no seas, still or flowing, and most daunting of all, because it looked like it belonged, there was absolutely no sign of life. But the creators of Viking remained undaunted. They knew not to trust first impressions. For Viking had been built to look deeper than the surface, to probe for life with two assumptions. First, it should be based on the element carbon, and second, wherever large life forms roamed, small ones did too, and would be far more abundant. If Earth was at all typical, a random plot of land would not have a single elephant, but a thimbleful of soil would be teeming with millions of microbes. And so, 8 days after landing, Viking began its real work. The equipment it carried, weather stations, laboratories, incubators, furnaces, would normally have filled a building. But the creators had done their miniaturization job well. And on that 8th day, a small boom uncoiled and stretched 10 feet to the ground. A scoop extended from the end of it, grasped a cupful of soil and placed it on the bed of a tiny railroad car. Thank you. The car climbed up a track, disappearing into Viking's guts, and the first search for life on another planet had at long last begun.
Buffer area will be located Dekho I-95 Zone 3 before Krumasi.
Ten-year-old Christopher Elkay would never know. Yeah. Stop. Got a lot of things going on here. 10-year-old Christopher Elkay would never know what made him switch on the old Zenith, the particular moment of that particular day when Viking sent back its images, but it would change his life. Propping a lanky frame against a bed, he mopped back a wave of sandy hair and leaned closer. His evergreen-colored eyes narrowed on an alien landscape and took in the pink sky's reflection. He shut them for a moment, trying to imagine what Chris Planescia would really be like and dreamt of a time when, instead of imagining, he might touch the sands of Mars himself. What did Viking find? Well, the first thing it found is that there are many similarities and many differences between Earth and Mars. A year is very similar. Twice as long, 667 days. The day is almost exactly the same, 24 hours, 39 minutes. The tilt of the axis is very similar as well. Sunlight, 44% of the sunlight that we get here, that's what you get on Mars. Gravity, 38% of what we have here, that's what you get on Mars. Temperatures range from minus 220 to plus 80. Temperatures range here from minus 150 to plus 120. So we have very similar temperature ranges. If you look at this image, you see widespread frost. We know it's frost because of the temperature regime, and it disappears very quickly, and we can't really see where it goes. And this led to a whole series of mysteries. Where did the frost go? Did it become water? Did it disappear? Did it sublimate? Did it evaporate? If we stay in the same place, can we see it happen again? All these questions were eventually answered. Soil composition is very telling. Here's the composition of soil. It's almost 50% silicates and iron oxides. Right? That accounts for the red color everywhere, aluminum, magnesium, calcium. If you go down that and you compare it to the typical soil on Earth, it's extremely similar, which means that the same processes that formed our soil of erosion, probably by weathering, formed the soil of Mars. But Viking, really, the main reason Viking was sent was to look for life. These kinds of things are one thing. Looking for life is something else. "42 years after Viking landed, the only sound in Chris Elkay's quarters came from CNN's coverage of the third attempt to get the first human mission to Mars off the ground. His wife, Tess Elliott, clung to him tightly. So tightly the rise and fall of his breathing was impeded, but he'd never say it. He wanted this suffocating closeness as much as she did, for they may never be this close again. She looked hard in his eyes, imploring him. Promise this wouldn't be our last few moments together, but she knew it might be. There could be another slip, but she sensed there wouldn't be. The moment she feared was finally at hand. One she'd share with only a handful of human beings." I'll put this on hold for a second. "My husband is leaving for Mars," she thought. "How do I handle that?" She looked at him in that way of hers, suspecting he had something to say, knowing it. What was it? "It's no time for secrets. I've been thinking about Ed Cochran, that's all," he said. Ed Cochran was Chris's first boss at JPL, and he'd gone nuts before dropping out of the program, or so it seemed, with fantasies of sabotage and swapped crew members. He flashed back to Ed's gravelly voice, barking at him, the day they met decades ago, when he said, "You might think Mars is the hottest thing you can do, son, but know this, you could spend a lifetime waiting for a mission and it might never happen." And then Ed had proceeded to tell him all about Viking. How its creators had pondered the question for years. Can life exist on another world? Would it be like ours or different beyond conception? Could you test for such life from 200 million miles away? What would one test for? Where would one look? The 3 tests on Viking were ingenious, taking over a decade to design. But as Ed Cochran and his team waited for answers, they were uneasy. More than anything, they feared the false positive, the answer that would say yes when it was really no. So they decided to make life the explanation of last resort. That was good science. That was the right thing to do. But science is one thing, dreams and egos are another. Gil Oyama had been the first to hear back once Viking landed. His experiment was based on the fact that all living things use oxygen and give off water vapor. So he sealed his cup of soil in Viking's incubator, drenched it with nutrients, and looked for changes. Suddenly, there was a spike indicating a burst of oxygen. It was a positive response, and he'd been stunned. Gil Levin, the president of a small environmental firm, had stopped his life for Viking. He heard next. His labeled release test was based on the premise that living things give off carbon dioxide from digesting food. The food in his experiment was a watery soup laced with radioactive carbon. And almost immediately, Viking's Geiger counter went off and did not stop for 9 hours. It was measuring carbon dioxide, and he watched incredulously as the curve precisely matched that for life. He repeated the test with the same result and then applied what he thought was the absolute coup de grace, commanding Viking to heat the sample to 323 degrees. If anything was alive, that much heat would kill it, he'd reasoned. The radioactivity stopped. His assistant could no longer hold back. It really looks like life, Gil. It really looks like life. The third and last test belonged to Norman Horowitz, a prominent Caltech biologist who'd studied Mars half a lifetime. Unlike the others, he was sure that the canals Percival Lowell saw through his telescope in 1893 proved life on Mars was a myth. To prove his point, he went to the one place that was most similar to Mars on Earth, the frigid, dry valleys of Antarctica, and there in windy crevices with no access to seas or streams, he couldn't find a single living cell. These crevices are a paradise compared to Mars, he told anyone who would listen after that. So when he built his test, he did it with a different kind of life in mind, one that could make food directly from sunlight. Photosynthesis of organics without liquid water, survival of the fittest. His experiment simply baked a soil sample with a sun lamp and measured the CO2 uptake into organic compounds. He had to wait a week longer than the others for his answers to come back, and when they did, he was the most shocked of all. What the devil does this mean, he said. Can it really mean life? But the day that happened was the first and last. All three tests agreed. Repeats yielded drastically different results. And when Viking 2 touched down, a month after Viking 1, it just multiplied the confusion. Life shouldn't look like this, Oyama said on reflection. The spike is too high. Horowitz concurred, blaming tricks. This is chemistry, not biology. But Gil Levin stuck to his guns because his results never changed. The arguments turned nasty. Your experiment's perfect. Ed Cochran heard Horowitz snap at Levin, except it was designed to detect life on Earth, not Mars. You're suffering from the delusion of a Mars with liquid water. I resent that, Levin shot back. If it's true, why did I get a positive response for a sample under a rock? And why did it stop when I put on the heat? There were no organics, Horowitz counted. You ignore the mass spectrometer. With no organics, you can't have life, and you know it. But that instrument was never meant to look for life, and you know it. And you've abandoned the scientific method, Levin howled back, losing his calm. Eyes locked an inches apart, the two men were about to jump each other until Ed Cochran jumped in, saying, "Enough. This has gone far enough." But you see, it hadn't. The room grew deathly silent because what everyone feared the most had reared its ugly head. The specter of the false positive that tore unity and consensus asunder. Nothing will stop it now, Ed thought to himself that moment. Nothing will stop it. So true. And at the end of the day, these scientists huddled and argued and fought and finally came to a consensus. We can bring up the lights a little bit, please. At the end of the day, Carl Sagan had to jump into the game and make this famous statement: extraordinary claims require extraordinary evidence. Now, I got to tell you, I know Gil Levin personally. I've known him a number of years. He is a passionate, smart guy, and to this day, he continues to sort through this data to prove that he found life. And he's got some good arguments. But you know what this speaks to? It speaks to the nature of science itself. And here we take a little departure. What is science? What is truth? What is fact? What is baloney? Cornerstones of science. This was used to help make that decision. Science starts out with a hypothesis. What is an hypothesis? An educated guess. It's an observation. Based on looking at something, you make an educated guess. That guy claims he was kidnapped by aliens. It's a claim. And then what you do is you start testing these claims. So a theory is a statement based on a collection of observations, a collection of hypotheses, and ideas assumed to be true, but they can still be wrong. Example, cancer is mostly genetic. Most of you probably saw the newspaper article yesterday that said, new studies show that instead of cancer being as a result of genetics, which a previous study had said, I think last year, it's mostly genetics, they're saying it is mostly environmental. They used the same data, they looked at it a different way, they came to a completely opposite conclusion. So that's what a theory is. It can still be wrong. And then you get into the next step, which is a law, a statement based on a collection of observations that most likely is not wrong, and then is considered to be a fact. There are exceptions. The biggest exception is you can't prove a negative, like prove the sky is not blue. So you can't prove a negative using this process. Then when you do this, when you do these studies, when you do these experiments like Viking did, they usually fall into two categories of experiments. One is observational, associational. In the medical industry, we call them epidemiological. Those are studies based on large number of statistics. That's how we found out that smoking causes cancer. Thousands, hundreds of thousands of people who smoke, many of them get cancer. The other kind of study is causation, cause and effect. Sometimes we call it experimental. That's when you actually look at a cell, you see a cancer cell coming and corrupting it, and it forms cancer under a microscope. I don't think we've done that yet. So these two things go hand in hand. Sometimes one of them, I spoke the other day about the China study, which was the largest epidemiological study ever done, associating disease with nutrition. When you get to a certain N, which is a sample size in science, and the results stay consistent, and you put it through a certain number of tests, it becomes believable. Even though it's only observational, it's only reports of this happening. You haven't done a single experiment, but it becomes close to fact. So that's how you look at this, but if all that stuff is too heavy and too much to remember, if you only remember one thing, extraordinary claims require extraordinary evidence. That's the thing to remember. And as a result of that, poor Gil Levin never received credit for finding life on Mars, because you see, other explanations started to come into as possibilities to explain his results. Chemical explanations. People looked all over the place to find an alternate explanation, and they found one. If there's another explanation, that extraordinary claim you made, you haven't made extraordinary evidence. Very soon there'll be a movie about Gil Levin and this whole thing. And there's also, the next step is just as, when it comes to Mars, you get these things happening constantly, constantly, constantly. The next one, 1996, ALH 84001. Maybe some of you remember President Clinton announcing on national television with a bunch of scientists next to him that we have found life on Mars. One of those scientists, David McKay, was a close friend. And David was a damn good scientist, I got to tell you that. And David was aware of the pitfalls of making such an announcement. But instead of using one chain of reasoning, that this little guy here was life found in a meteorite that had been laying around in a laboratory for a number of years. He used 5 separate chains, 5 separate independent chains. And there's a book about this, a fascinating book called The Mars Meteorite. It does not read like a dry scientific thesis. It reads like a novel because it's all about the people battling each other to believe this happened, or this was science, this was life, this was not life. It's fascinating. You might even be able to find it in the library. It's pretty popular. So, at this point, NASA started to give up the ghost and say here, you know, it's really difficult to prove life. So rather than proving life, why don't we go to Mars and look for the telltale signs of life, primarily water. And at this point, we started to send probes that looked for water and looked for signs of life. And the first one that was really mobile was Little Mars Pathfinder. And here you see it up against a rock. And it was also, by the way, in The Martian, the movie The Martian, and in the book The Martian. It didn't look for life, but it did find Mars to be, as opposed to that first image that came back of a pockmarked surface, it found a place interesting, friendly, stranger than anything we'd seen before. And the website hits at the Mars Pathfinder website went through the roof. Over 1 million an hour. People were really interested in this. And then came the big breakthrough. Spirit and Opportunity launched in 2004, the Mars Exploration Rovers. They were launched and landed on opposite sides of the planet. Spirit in Gustav Crater, Opportunity in Meridian Plenum, which is a big plane. You can see how far apart they are. As of September of this year, they've been there despite a 90-day expected lifetime. They've been there over 12 years, 39 times the expected life, over 500,000 images returned from the opposite sides of Mars, well over a marathon of driving. Opportunity is exploring Endeavour Crater. It's probably gone beyond that. At this point, and Spirit is inoperative. It's one of its wheels got caught in the sand and it couldn't pivot to face the sun and its batteries died. These rovers carry a host of instruments, interesting instruments. A panoramic camera, the RAT, which is a rock abrasion tool for exposing fresh rock surfaces, a miniature thermal emission spectrometer for mineral detection, soil temperature, another spectrometer for iron identification and the role of water in weathering, an X-ray spectrometer for rock composition and element concentration, and finally a microscope. So let's take a look at some of the images, and we're going to be looking at images from high and images on the surface, because in order to have these rovers work, they have to send their signals back to Earth. They can't do that independently. They have to send it up to a satellite, and there's a satellite circling Mars constantly, and that receives the images, stores it, and sends it back slowly for us to pick up. So some of these images from orbit show older features like this that look like water or some material is running through them. And you might be familiar with what a delta looks like on Earth. And here is a delta, the typical fan-type appearance at the bottom of a gully on Mars. Obviously something was flowing here, but just by the coloration and by the appearance of it, it sure looks like water. This also looks like water, and this looks like water much more recently coming in from the top of a crater rim. You see all these trails, because if this had been there 1 million years, 500 years, 1,000 years, 50 years, 25 years, you would not expect, with winds blowing all over the place, sometimes at high 300 miles an hour, you would not expect such sharp divisions to have occurred like this. You get craters that are filled with ice and snow on the edges of these craters. Here's some more indications of things that came in and had to be recent. It looks recent. Anybody that's ever been to Petra, Jordan, can look down the rim of the high mountains, and you can see the same kind of trails, telltale trails. This is caused by water runoff. You go to the South Pole and you look at some of these images and you see odd structures protruding through ice over here. So this is just some views from high above. But let's go back and get on the surface and see what the rovers actually see through their eyes. So here is Spirit on landing day as it's sitting on its carousel about to roll off into the distance. And here is Opportunity on its way. And you can see here it's just made a run around during its check into the sand. Initially, these were targets of Opportunity. We're going to visit these places that were going to be established. All of them have long since been visited. And then you get the closest one was the East Hills, 2 to 3 kilometers away. And here you get, it's hard to see this, how wide this is. This is a Victoria crater where Opportunity went in and looked. And you've got to have a lot of nerve to take something you've invested so much in and just plop it over the side and come down into this and come up again. That really takes a lot of nerve to pull that trigger, doesn't it? Here is Spirit traversing Gusev crater, and it looks like a very friendly place, not too many boulders, not too many rocks. Here you see a hazy sky. Two different days, and you see haze and not haze, kind of like Los Angeles Basin. This is a picture, infrared picture, that the infrared spectrometer took to give an idea of what the temperatures are. This was a 3D stereoscopic image. If you had these 3D glasses, red and green, you'd be able to actually experience the 3D view. Opportunity, unlike Spirit, hit pay dirt when it landed. It landed at a series of outcroppings. So outcroppings trace the history right down to the core. It's not covered by sand. You don't have to dig things away to find out what the early history is. It's right there. And here are these outcroppings. Here you see an abrasion tool that was used to dig away at some of the rock, and we'll talk about that in a second. Close-ups of some of these rocks that were done, and here's an image of the rock abrasion tool digging into this rock, clearing away the old stuff so you'll have unspoiled virgin material to look at and put into the instruments to determine what it's really made of. But when this picture was taken, something very interesting showed up. All these little tiny pebbles. Now, they were nicknamed blackberries, and they were very interesting. They seemed to be there everywhere you looked. And people recognize this, you see, because in southern Utah, they call these things Moki marbles. You see them? And they're formed in solution in running streams, waters, and rivers. That's the only place they're formed. And yet, here they are, all over the place. And so you can see what's happening here. Evidence is accumulating towards a place that had a lot of water, but doesn't anymore. Here you see some of these blueberries in a flow stream. Here's the flow stream. Here's some caught in the flow stream. Here's a classic one. This blueberry is caught in between the crevice here. So it was obviously pushed by something flowing into this crevice. Now, this is interesting because it gets down to the point of what's science, what's imagination, what's real, what's not real, everything we talked about before. This is a picture that looks very much like a beachhead, doesn't it? So here's the deal with this. The rover drivers at the Jet Propulsion Laboratory, they look on images from on high each day, and they take a plot of where they want the rover to go and next. And they usually plot 20, 30, 40 meters ahead. And they look at all around and see where it would be dangerous, where the rover might get trapped, where it could fall, where it could get into trouble, and they avoid it, so they plot a path ahead. Now, imagine, since the time distance, to send a signal to a rover, to tell it to move and turn a wheel to go away from a dangerous area, can be as much as 20 minutes. In other words, if the rover detects something as it's moving along, and it's a crack, a crevice, a boulder, whatever it is, and it sends a signal back home, it's going to take 20 minutes for that signal to get back and 20 minutes to go back the other way, and by that time the rover's already fallen into a hole and is gone. So you can't take that kind of chance. So it's all plotted out very carefully. 30, a day at a time. 30, 40, 50 meters at a time. And that's how it's done. And that's how it's kept safe. But there's a downside to that. Each day, it's got to move ahead. And this image does not come back that same day. Sometimes this image takes weeks to come back before you see it. So by the time you see this, opportunity's far gone. And now you have to make a decision. Are you going to turn around and go back to that spot, or are you going to continue exploring? And that's what you do. You continue exploring, but you miss a beach, a possible puddle, a possible flower, probably have trouble seeing this, but this looks like a spoon that's suspended over the ground with a shadow underneath it. What on Earth, Mars, is this? It's actually a vent tube from probably an ancient volcano at some point. How about this? What is this thing? What about this? Now you don't see this on Sol 3528. Now 3540, 16 days later, you do see it. What's that? Maybe it was blown by the wind. But these are all still images, and sometimes you say, well, this still looks like a dead place. It could be a lot of circumstances, wind blowing, and then every now and again, you see something like this, right in front of your eyes. Better yet, how's this one, complete with shadows? And again, this one was recently put together. It shows what looks like a repeatable pattern of water that's very recent and probably liquid if you watch.
And it's all along the north-facing and west-facing rim of this crater. You can see the black arrows pointing to many of these on the left. On the right is this animated GIF, and it shows the sequence where these start to form in the early summer. They grow either gradually, very gradually, or incrementally. Then they stop growing and they fade. Then they disappear. They're gone entirely for most of the Mars year. The following Mars summer, new features appear and grow that are very similar. This means that the source of hydration, or the source of molecular water in the crystal structure of the salt itself, is.
Well, anyway, you get the picture. This is a dynamic place, as opposed to when I first started getting involved, people said water could not exist in liquid form anywhere on Mars. It would sublimate. It goes, in other words, go directly from ice to a vapor. It would never pass through a liquid phase. And then we did some very creative experiments at Berkeley where we took an ice cube, put it in a Mars bell jar, reproduced the Martian atmosphere, and shined some light on it to get the temperature above freezing, and lo and behold, it started to drip. It didn't disappear. It dripped. And that was the first. And then we published a paper. A bunch of undergraduates published a paper, which was actually the first paper that proved that conditions are right for liquid water to be liquid on the surface. Now, once you start getting to the point of water being liquid, not snow, not ice, but liquid, then you open up a whole box of questions about life, because that's what you need for life. So we don't know where it is. Now, speaking of that, was a couple of years old, Opportunities at Endeavour Crater. You can see where it was most recently. It's a beautiful area. Let's see, you can't see much about that one. We looked at that already. So where did all the water go? Where is it? And speculation is rampant that it disappeared, evaporating eventually all the seas and oceans, which are, at one point, scientists think Mars was covered with the equivalent of large oceans, seas. The entire planet, if you mix the water up and cover the planet, would be something like 9 feet high. But none of it's there now. It comes in and sneaks. You can see it in these little images that come and go. You see, I just missed it. I missed it. It was there yesterday, that kind of thing. But then we had another lander, the Phoenix lander. It wasn't mobile, but it dug right beneath the surface with this arm, and there it was, without any trouble, without any difficulty. Permafrost was right underneath the surface. And then we get to Curiosity. Curiosity is the largest laboratory we've ever landed. It is now operating in full tilt, and data is starting to come back. And so I'm going to leave it right here for now, because part 2 will cover Curiosity and we'll cover human missions, where we intend to go if we can go there. So that leaves open the floor for questions. Bring up the light. Anybody have questions, I'm happy to answer them. They're all...
How big is that machine dimension?
Oh, well, Curiosity is the size of a small car. A couple of thousand pounds.
Excuse me. I have a question.
Yes, somebody else?
I recall some years ago, science requires reproducibility in experiments.
I don't know where are you? Could you stand up?
Up there.
Oh, okay.
As I recall many years ago, science requires reproducibility.
Yes.
I don't see reproducibility here. I see individual events, whatever.
You mean in what?
Whatever you're showing. Someone did something, found something, the next guy can't.
Well, okay, reproducibility. How do you reproduce the fact that you see an image of water on Mars? Is that what you're...
I'm not doing the experiment.
I mean, you look at many, many observations, and that's what we've seen multiple times all over the planet. Many, many, many observations of this effect, of what's now considered to be fact. It's gone from hypothesis, it's gone to theory, and it's now considered to be fact. And it doesn't mean that it won't change in the future. Other questions? Yes?
Are there any plans to send something up that can drill down and see if there's, we have a lot of subterranean water on this planet.
No, there's no plans to drill that deep. There are plans to send drills. There's even plans to bring a sample back. But when you just scratch the surface and you see permafrost, there's something else going on. And really, I didn't really get into the details of what Cassie's Guess, the novel, by the way, is about. It's about the environment. It's about where did the water go? Where did the atmosphere go? Where did the temperature go? Is there a lesson for Earth? That's what distinguishes Cassie's Guess from The Martian, because in Cassie's Guess, you see the scientist decides he's stranded on Mars because he wants to be stranded on Mars. He can't get his answers. He hasn't found his answers in the time allotted, and they're getting ready to go back to Earth. And he can't accept the fact that he doesn't know, this fellow Chris I was reading about, he can't accept the fact that he doesn't know what happened here. In The Martian, the guy just wants to get out of Dodge. His life is just a survivor story, right? Other questions? Yes?
How did Mars lose its atmosphere? Or even get today?
Question is, how can Mars lose its atmosphere? And theory. As the size is too small to hold the atmosphere. Up at the very edges, it kind of disappeared. Or once the atmosphere started to get lower, for whatever reason that happened. The other theory is it combined, because it's all carbon dioxide, it's not oxygen, the atmosphere is mostly carbon dioxide. The surface is full of a lot of clays, and so as a consequence, you had carbonates building up. You had the carbon dioxide in the atmosphere combining with the clays, forming carbonates. Now on Earth, we have tectonic plating. We have massive subduction of the surface. And it's a cycle. So we grab carbon dioxide, we grab our atmosphere, it goes down, and then it comes bubbling back up. We release the carbon dioxide back into the atmosphere, and it's a process. There is no tectonic plating on Mars. And so the other theory is it's all beneath the surface. It's all in the form of clays. That's where it went. And once it started to disappear, the pressure wasn't high enough to keep large bodies of water liquid. So the temperatures changed, it got very cold, it all became permafrost, it's all under the ground, and theories like that, and those are theories, are validated when you take a scoop, you go to the middle, any place on the surface, you dig it away, and there you see permafrost. It kind of builds a story. But again, it's not repeatable enough times to make that hypothesis or that theory into a fact. Other questions? Yes?
What would need to happen to speed up exploration so that the government would increase funding?
Well, what would need to happen to speed up exploration so the governments would get involved? And there's probably nothing humanly possible that we can do. In the next talk that I'm going to give, part 2, you're going to see just how many times that has been attempted. You'll be flummoxed when you see how many times initiatives have come across to try to do this. And at the end of the day, there's a pendulum going back and forth, and you're left with the thing that it's got to be circumstance, it's got to be an individual. And I've said this before, I don't think the Apollo moon landings would have happened without John F. Kennedy. It was a confluence of events. It was not just John F. Kennedy, it was a Sputnik that was putting fear in everybody. It was a Cold War. It was the nuclear bomb age. It was a quest for science. It was a lot of things that came together, all spearheaded by a person who knew how to manipulate it and could do this. And so you might say this confluence of events could never happen again, and we would never be able to do this again. But every maybe 40, 50, 60 years, somebody comes along who can do that. And I'm hoping that that guy is Elon Musk, because he has all the characteristics of it. He has lots of money, lots of passion, reckless abandon, not afraid to lose everything he's worth. And this is his #1 passion. He's got electric cars, he's got SpaceX, he's got Solar City, he's got designs to speed trains from Los Angeles to San Francisco in 30 minutes. He's got unbelievable ideas, and he's got the tchotchkes, as we say, and the money to do something about it, and the passion. So a guy like this does not come along often. And I think I mentioned that in order to get Tesla in the black, because for those of you who don't know Elon Musk's history, he was a co-founder of PayPal. That's where he made all of his money. And then from PayPal, he went out and founded Tesla Motors, and then SpaceX, and then Solar City. But at one point with Tesla, he needed everything he had and more in order to make it over the top. And he put every penny he had, and he went to his co-founders at PayPal and said, I need you to help me out. And he was at that point on paper completely bankrupt. But that's the kind of person who's willing to do this and take that kind of chance. And so I'm kind of starting out as a skeptic and hitching my wagon to this guy, because we have such a sordid history of attempting to get to Mars. And this has nothing to do with why we should go, really why we should go, which we'll talk about in the next talk, why we should really go. But I mean, he believes it, I believe it, other people believe it, so. Other questions? Nobody? Okay, great. We'll see you all tomorrow. Thanks for coming.